Good evening, everyone. My name is Pranav, and I'm studying in Institute of Aeronautical Engineering, which is also known as IRA, BTech, first year, second semester. And today I'm gonna talk about one of my favorite subjects topic, which is the treatment of chromate wastewater with iron copper internal electrolysis coupling with bentonite. So, coming to the introduction, in industrial activities such as electroplating, leather tanning, dye manufacturing, and metal finishing, often produce wastewater containing chromium compounds. In many cases, chromium exists in the form of hexavalent chromium, which is highly toxic and harmful to living organisms. Chromate wastewater can contaminate soil and water resources if it is not treated properly. Therefore, effective treatment methods are necessary to reduce the chromium concentration before disposal. One promising method for treating chromate wastewater is iron copper internal electrolysis combined with bentonite adsorption, which improves removal efficiency. So, the coming to the chromate wastewater refers to the water contaminated with chromium compounds, particularly hexavalent chromium ions. This type of wastewater is commonly generated from several industrial processes. Chromium in wastewater mainly exists in two oxidation states, Cr3 plus, which is trivalent chromium, and Cr6 plus, which is hexavalent chromium. Among these, Cr6 plus, which is hexavalent chromium, is more toxic and more soluble in water due to its high mobility and toxicity. Hexavalent chromium can easily spread through water systems and cause serious environmental pollution if not treated properly. So, coming to the environmental and health effects, hexavalent chromium is considered highly dangerous to both humans and ecosystems. It can cause severe health problems when people are exposed through drinking water and industrial environments. Long term exposure to chromium compounds may lead to respiratory problems, skin irritation, kidney damage, and even cancer. In aquatic environments, chromium pollution can harm fish and other aquatic organisms. Therefore, effective removal of chromium from wastewater is essential to protect human health and the environment. So, the need for treatment of chromate wastewater is because of this high toxicity of hexavalent chromium. Untreated chromate wastewater cannot be discharged directly into rivers, lakes, or groundwater system. Environmental regulations require industries to treat chromium containing wastewater before releasing it into the environment. Traditional treatment methods sometimes have limitations such as high cost, low efficiency, or generation of secondary pollutants. Therefore, improved treatment technologies are required. So, the iron and copper internal electrolysis method is introduced. This iron and copper internal electrolysis process is an effective technique used for the removal of heavy metal ions from wastewater. In this method, iron and copper particles form a microelectrochemical system when placed in water. Iron acts as the anode while copper acts as the cathode. This creates small galvanic cells that generate electrons and promote electrochemical reactions. These reactions helps convert toxic Cr6 plus ions into the less harmful Cr3 plus ions, which can be removed more easily from the wastewater. So the working principle of this internal electrolysis is when iron and copper particles come into contact in an electrolyte solution, they form a small electrochemical cell. Iron undergoes oxidation and releases electrons, while copper acts as cathode, where reduction reactions occur. These electrochemical reactions help reduce hexavalent chromium into trivalent chromium. The reduced chromium ions can then participate as insoluble compounds, allowing them to remove from the wastewater. So the role of bentonite is a natural clay mineral that has strong adsorption properties. It is widely used in environmental treatment processes because of its high surface area and adaptability to absorb pollutants. In chromate wastewater treatment, Bentonite acts as adsorbent and captures chromium ions from the water. When combined with copper and iron internal electrolysis, bentonite improves the overall removal efficiency by absorbing chromium ions that remain in the solution. So coming to the coupling of iron copper electrolysis with bentonite. The combination of iron copper internal electrolysis with bentonite creates a more efficient and effective treatment method for chromate wastewater. In this process, the internal electrolysis system first converts the highly toxic hexavalent chromium into the less harmful trivalent chromium. Once the chromium is reduced, bentonite plays an important role by absorbing chromium ions and other impurities present in wastewater. Due to its large surface area and strong absorption capacity, bentonite helps capture remaining pollutants that are not removed during electrolysis. This combined treatment process significantly increases the removal efficiency of chromium and improves the overall quality of treated wastewater. Coming to the advantages of combined method, the copper and iron internal electrolysis coupled with bentonite offers several advantages in the treatment of chromate wastewater. One of the major advantages is its higher efficiency in removing toxic chromium ions from contaminated water. This method does not require complex equipment and can operate under relatively simple conditions. The materials used, such as iron, copper, and bentonite, are inexpensive and easily available. Another advantage of the process is it generates fewer secondary pollutants compared to many traditional chemical treatments methods, making it more environmentally friendly solution. So the chemical reactions involved are during the internal electrolysis process, iron acts as the anode and undergoes oxidation. This oxidation reaction releases uh, electron into the system. These electrons are used in reduction reactions that convert hexavalent chromium ions into chromium ions, which are less toxic and easier to remove from wastewater. For example, if the reaction happens, if we take the iron reaction, it gives like Fe2 plus 2 electrons, and the Cr6, which is chromium ions plus electrons, gives rise to the chromium ions Cr3 plus, which is less harmful. After the after the reproduction process, the Cr3 plus ions can form in insoluble hydroxide compounds which settle down and can be removed by using the filtration method. So the factors that affect treatment efficiency are there are several factors involved in it, which influence the efficiencies of chromate wastewater treatment using iron copper internal electrolysis and bentonite method. One important factor is pH of the solution. As chromium reduction reactions are highly dependent on the acidity or alkalinity of the wastewater, other factors include the amount of iron and copper particles, the dosage of bentonate, and the contact time between wastewater and treatment materials. By optimizing these parameters, the treatment process can achieve higher chromium removal efficiency and better overall performance. So, coming to the industrial applications, the iron copper internal electrolysis is combined with bentonite treatment method has many practical applications in industrial wastewater treatment. Industries such as electroplating plants, metal finishing industries, leather tanning factories, and chemical manufacturing units often generate wastewater containing chromium compounds. This treatment method provides an effective solution for reducing chromium pollution and ensuring that the wastewater meets environmental safety standards before the discharge. So the environmental benefits using this treatment method provides significant environmental benefits. It helps prevent toxic chromium compounds from entering rivers, lakes, and groundwater systems by converting harmful hexavalent chromium into less toxic element chromium and removing it from wastewater. The process protects aquatic ecosystems and water resources. This method also supports sustainable industrial particles by reducing environmental pollution and promoting safer wastewater management. So the limitations of this method are, although the iron copper internal electrolysis coupled with bentonite metal is effective, it still has some limitations that should be considered. The efficiency of the process may decrease if the wastewater contains other competing ions or complex chemical substances that may interfere the chromium reduction. In addition, the periodic replacement or regeneration of the bentonite and metal particles may be required to maintain consistent treatment performances. And coming to the future improvements, the future research can focus on improving the efficiency and performance of iron copper internal electrolysis systems used in wastewater treatment. Scientists are exploring new materials with better absorption capacity and higher durability to enhance chromium removal. Combining this method with other advanced treatment technologies such as membrane filtration or advanced oxidation processes may further improve wastewater purification. Coming to the conclusion, the treatment of chromate wastewater is extremely important for protecting environmental and human health. Industrial wastewater containing hexavalent chromium must be treated before being released into the environment. The combination of iron copper internal electrolysis with bentonite adsorption provides an effective method for reducing toxic chromium contamination in wastewater. This process converts the harmful Cr6 plus into less toxic Cr3 plus and removes it through electrochemical reactions and adsorption mechanisms. With proper optimization and implementation, these technology can play a significant role in industrial wastewater treatment and environmental protection. Thank you.